Hello guys, welcome back to my YouTube channel. Today we'll be looking at C++ programming, and I have a question here today. The question says write a C++ program to find the roots of a quadratic equation x equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a, giving that b is equal to b squared minus 4ac. Now, in order for you to be able to solve this or write this using C++, you need to understand how to solve quadratic equation. So this is a formula that is given to us. We have to translate this formula into C++ code equivalent, right? And the purpose is to solve what? Quadratic equation. Now, from this formula, our variables here or our name here are what? A, B, C, right? These are what is going to determine the roots of our equation. And as we all know, quadratic equation, we ought to have two roots, root 1 and root 2. But these two roots can come in three different forms. That is, you can have a scenario or you can have an instance where the first root of this solution will be different from the root 2. That is, we have the distinct roots where root 1 and root 2 are real and different. For example, after solving the quadratic equation, it is possible that your root 1 can give you 5 and root 2 can give you 3. You see, that means root 1 and root 2 are not the same, right? The second instance is where root 1 is equal to root 2. That means your root 1 is having the same value as root 2. That means they are equal. Then the third instance is where your root 1 and root 2 are different, but they are complex numbers, right? What are complex numbers? Complex numbers are numbers that are having a real part and an imaginary part. You can see this is why it is important that you need to know how to solve a quadratic equation using that formula stated above. Because if you don't know how to do this, then maybe probably you don't even know about the complex numbers. Now, in order to solve this using C++ program, I'll be using a well-known IDE, C++ IDE, which is known as Dev C++. If you don't have this IDE, you can go to the internet and download one and come back and continue from where you stopped. Now, this is the Dev C++ environment, right? And in order to begin, you create a new file by clicking here, or you come to the file menu here, click on it, go to new, and click on new source file. Depends on you, anyone you wish to do. The next thing is to save the file and click on save as, right? Then we'll give it a name. In this case, let me give it I have one quadratic equation here. Let me quickly delete this so that's alright. So I can give it the name, let's say quadratic 1, right? You can give it any name you wish to, and you save. Now, in order to begin, by convention, I like to write comments on the beginning of the program to indicate what the program is meant to do. So, like in this case, this is a program to find the roots of a quadratic equation, right? So, the next thing is we need to include our header files. And I believe most of you are already familiar with it, right? We have a hash include IOString. This is not new to most of us. And we have the using namespace yesterday, right? So the next thing is to write out our test driver, which is our main function, right? Which is int main, without passing any argument, and you open your open and close braces, which indicates that whatever is in between this open and close braces is under this function called what? Main. So from here, let's quickly go back to that slide and look at our formula, right? Remember that the x here is representing two values, root 1 and root 2, as a quadratic equation. But on this side, we have three variables, right? A, B, and C. which is dependent on the user. The value depends on the user. So these are our variables, including the x1, the root 1, and the root 2, which is being represented by x. Right? In this case, I'd like to call this the a, b, and c as the independent variables, and the x, which is representing root 1 and root 2, as the dependent variable. Why? Because root 1 and root 2 is depending on the values of a, b, and c. As the values of a, b, and c changes, so does root 1 and root 2. Right? So now another thing I want us to look at is this formula here. D is equal to b squared minus 4ac. Remember we said we have three possible kinds of values, roots, right? We said we have the distinct roots where we have root 1 and root 2 are real and different. We have the equal and identical, and we have the complex. Now, as a human being, normally solving a quadratic equation, you will not realize there is much difference until when you just encounter any of them and solve it. But this is a program. It follows a set of instructions, right? So we have to specifically tell the computer how to arrive at an answer in a defined way. So in order to do that, we need to bring out this formula, b squared minus 4ac, which is gotten from this part, right? It's gotten from this part, and assign it to a variable called d, right? This is known as discriminant, and what it does is that it determines if our roots, our final roots of the equation, is going to be either distinct, equal, or complex. Now, how does it do that? Now, it is distinct when d is what? Is greater than 0. That means d, which is b squared minus 4ac, the value is greater than 0. Then we know we are going to have what? Distinct roots. Then that means we are going to have different root 1 and different root 2. Right? Now, how do we know we are having equal roots? It is when d is now equal to, d is now equal to 0. It means we are going to have what? Equal or identical roots, where root 1 and root 2 are equal. Right? Now, how about the complex? The complex root is where we have d less than what? Less than 0. That means we are going to have a complex root, right? Where root 1 and root 2 are complex numbers. So, having this in mind, we can proceed to our dev C++ environment and start with the comments, initialize variables, right? And we said our variables are a, b, c, including root 1 and root 2. And do not forget that we are now including another variable which is known as what? The discriminant, to hold the value of b squared minus 4ac. And all this, there's a possibility of them having what? Decimal point values, decimal points. So now, since that is the case, we already know that float and double are compatible for holding values that have decimal points, right? So we can just go ahead and declare them as floats, a, comma b on one line, comma c, comma d for the discriminant, root 1 to hold the value of root 1 and root 2 to hold the value of root 2. Now, this is our variable declaration. Now, going back to the formula, like I said earlier, that a, b, and c are independent, right? That means they are gotten, that is in regards to this formula, right? They are dependent on the user, but in this formula, root 1 and root 2 are only depending on b, a, and c. So now let's try to get our variables a, b, and c from the users, right? So get values of a, comma b, comma c from the users. Now, in order to do that, we need to tell the user a particular value to enter at a point in time, right? Normally, we can use cin to get values and cout to display, right? Cin has a function of getting the values from the keyboard. Now, but how does the user know exact value to enter at a particular point in time. So we need to use the CL to guide the user in this. So in the first one, we want the user to enter the value of A, right? Enter the value of A and we terminate this. And we see in whatever the user enters into the variable A, right? We do the same thing, we just copy and paste and copy this, Ctrl C and Ctrl V. So enter the value of B, right? So and C in into B. Now the last one is enter the value of C and C in into C. Now we've gotten all our variables from the user. The next thing is to calculate our D, our discriminant. That will determine if our root is going to be equal, distinct, or complex. So this is the formula, right? D is equal to B squared minus 4AC. So we have calculate, right? The discriminant. Here we have D equal to, right, B squared, that means B times B minus 4 times A times C. These are discriminants, right? And from here, what we need to do is we need to compare. We need to start applying these rules, right? If D is greater than 0, we know it's distinct. If D is equal to 0, we know it's equal. And if D is less than 0, we know it is complex. So let me quickly write that as a comment, right? If D, right, start with greater than 0, right? If it is greater than 0, then you know that we have distinct roots, right? And if we have, if D is equal to 0, you know we have equal roots. And finally, if D is less than 0, right? If D is less than 0, then we know this is going to give us complex roots. Now, what we need to do is to implement this using our if, right? In C++, write if, you open your brackets, we are going to put the condition, right? And the condition here is if D is greater than 0. Now, if D is greater than 0, whatever will happen, you put it inside the open and curly braces. What do you want it to happen? Now, if D is greater than 0, what we do is, from this formula, we split it into two, adding two different formula. That is, our root 1 is going to have the value of minus B plus the square root of B squared minus 4AC divided by 2. And our root 2 is going to have minus B minus the square root of B squared minus 4AC over 2A. Now, this is it. We call our variable root 1 is equal to minus B, right? We have our plus. Now we need the CMAX here, so that we can be able to use the square root function, right? So we have square roots, the square root function. So we're finding the square root of B squared, right? That is B times B and minus 4 times A times C. So remember, please take note of the formula that this the square root is square root of the determinant, right? Square root of the determinant. So we already have this, so you can just remove it and put what D, square root of D. So here you should also take note that the division, we are dividing all the expressions at the numerator by the denominator. So in order to do that, to avoid this order of operation, you can just use parentheses to specify the root order that we want, right? So that means all this will be done together. Then what we have will be what? Divided by 2 multiplied by A. Now, this is for root 1. Root 2 will also be similar, right? We have root 2, but the only difference is root 2 is going to carry minus, right? together. So what is happening here is if d is greater than 0, we know it's going to give us 16th root, where root 1 and root 2 will be different. So the first root is going to have the value of minus b plus the square root of d. Our d is now representing what? The p square minus 4ac, which is our discriminant, right? Divided by 2a. So we just split the formula, the initial formula, in total to give us two different roots. Now we have our else if, right? We have else if, and we have the condition. So here at this point you can decide to display, right? You can see out, say the roots are extinct and means their number nothing more, right? And I'd like to use the end line here to push it down, right? And I can see out the values. We have root 1 is equal to, and I have root 1, right? And also end line, and we just copy this, Ctrl C and Ctrl V. So root 2, right, is equal to root 2. Now, so what next? Let's continue from our condition. We go back to our condition. We have d, right? For the second one, which is the second one from d. When d is equal to 0, right? D is equal to 0. Now, this statement that this is just an assignment sign. We need to use double equal to signify equality, right? So if d is equal to 0, that means we are having equal and identical roots, where root 1 and root 2 are real and identical or equal, right? So since they are equal, we can choose to just use root 1, right, equal to, and copy this, Ctrl C and Ctrl V, right? So there's no much different from extinct. The difference is that root 2 is now equal to what? Root 1, right? They're having the same value. So you can see out also, and we have the roots are equal, and now we close this, then you move down. So you have your okay, let's do this, Ctrl C, Ctrl V, and delete this 9. We have C out root 1, right? Since the roots are equal, root 1 is equal to root 2, right? Which is equal to root 1. So what this means is that root 1 is equal to root 2, telling the user that okay, root 1 is equal to root 2, and the values are this, right? So you can format the output the way you like. It doesn't really matter. So we have the last condition, else if, right? Else if d is less than 0. Now, if d is less than 0, we now have the complex. Now, in order to implement this complex, we need to add two more variables. We need to have the real part variable and the imaginary part variable. Now, what this is used for is for those of us that are familiar with solving quadratic equation. The real part refers to the real number there, the number that is there, and the imaginary part is referring to the part that is having a negative square root. Now, just to quickly brush it up, you know, b square minus 4ac, right, is being represented as d, and we said if d is having a value that is less than 0, that we should name it as complex. Now the reason is that if we have a value of minus 1, from here we have a value of minus 1, use it as a comment, when d is equal to minus 1. Now if d is equal to minus 1, that means in this formula we are going to have minus b plus or minus square root of minus 1. over 2a. And mathematically, it is impossible to find the square root of a negative number, right? Even the computer cannot do that. It is impossible to find a negative number. So we have to find a way. Well, we all agree, even though that we cannot find the values of the square root of negative numbers, that negative minus 1 is being assumed to be what? I, which is an imaginary number. So we need to apply this concept and find a way programmatically to solve this problem. Now, in order to do that, we can decide to split this formula. When we split the formula, we're going to have it as minus b, right? Plus or minus. Now, the square root of b squared minus 4ac. Now, minus b is going to, since they are sharing the same denominator, minus b is going to be divided by 2a, as well as plus or minus square root of b squared minus 4ac will be divided by 2a. That is, we are going to have our b, right, divided by 2a. Sorry, 2a. Then we have our plus or minus, right? Plus or minus. Sorry, minus. Then we have the other part, which is square root, right? Square root of b squared. Let me use square root of b times b minus 4 times a times c, right? Also divided by 2a. This is because they are sharing the same denominator. So if you should find the LCM to simply bring it back to this equation here. Now, since this is the case, we're going to use this particular line code to derive our formula for finding our imaginary parts for the first root and the second root 1 and root 2. Now, in order to do that, we should look at this and assume that and say, okay, this part will not give us it will give us a negative number, but yes, it's solvable, right? And this part, that's d, remember that d is less than 0 here. So that means here we are expecting a negative value of d minus d, right? Minus d. So that means here becomes our problem. This is where we are going to get our imaginary from. So in this case, what we need to do is to call the real parts variable, right? And assign the value of minus b divided by 2 multiplied by a. That becomes our real part. This is not giving us an issue. But here we have an issue. And the issue is, now, we want to forget about the minus or plus, right? Let's focus on the square root of that negative number divided by 2. Normally, we have to have imaginary, right, representing it is equal to, now, we have square root of d. Remember that d is giving you a negative number already. Since it's a negative number, since it is less than 0, that means it's going to have a negative value. So square root of d divided by 2 multiplied by a, right? In this case, for example, to make it clear, let's say our d, after solving this, our d is giving us, our d is now equal to minus 2. Now, if our d is equal to minus 2, that means this will not be executed because minus 2 is less than 0. It's not greater than 0. It's not equal to 0, but it's less than 0. Right? That means this will be executed. That means our d here is already minus 2, right? And we are going to have minus 2 here. Now, if you attempt to run this, the compiler is going to give you an error because you can't find the value of a negative number. But we want this to become our imaginary part. Now, what we need to do is, now, since we already know it's going to have a negative number, what we can do is, okay, we can multiply whichever value is going to be there by what? Negative. That is, we can say, okay, we have, sorry about that. We have simply minus d. Now, meaning that whichever value is d is going to be multiplied by minus. In this example I just brought, where I said our sorry, I cleaned it. Our D is equal to minus 2. In this case, we will now be having D, we will now be having minus 2. So automatically, this minus is going to change. This minus will multiply this and become what? A plus. So automatically, it will now become what? To become positive 2. So here we can find the square root of positive 2. So that is just the trick in solving it. So we now have minus into D, right? Minus into D as our imaginary part. So since we now have it, we can now calculate for our root 1. Now, remember that this is an imaginary part, right? So when displaying the output, we need to specify it to the user so that the user knows that this is the imaginary part. So here, if we try to use root 1, right, to assign the values of the real part and the imaginary part, let's say we want it to be the real part, right, plus, right, using the first plus imaginary part. Now, this is going to give us an error. At first, it will not give us an error, but you know that this imaginary part, you need to specify, you need to concatenate it. You need to concatenate it with what? With I to indicate that this is what? Imaginary part, right? And once I is being concatenated to it, now it becomes very hard for the computer system to be able to add this number plus this that is now having a number and what? A character. So in order to avoid that, we can just simply, since we are not using it for any further calculation, we can just see out, right? We can see out and say the roots are real and complex. Yes. Then we can limit this. We have C out. Your C out. We can now have root 1, right? Root 1 is equal to, now here you now have your real parts, right? You have your real parts, you concatenate it with plus, right? Start concatenating it with plus, then you concatenate it with the imaginary part, imaginary part. Then you also concatenate the imaginary parts with what? I, right? Concatenate with I, then you can end line, and we do the same thing for the second. But the only difference is going to be that this is going to have minus instead of plus. So from here, we now have root 1 is equal to real parts plus imaginary parts. Imaginary parts will be concatenated with I and concatenated with real part. Then also this, the only difference is just the minus. So we can clean up this, right? Clean up this also, and let's look at this. So now in order to run the program, you can go to execute and compare and run. See if we have any errors, and hopefully we don't. So enter the values of A as 1, values of B as 2, and 3. So you can see the rows are real and complex. We have root 1 equal to this, and root 2 is equal to this. Now, the reason why we're having everything joined here is because here, let's see, we have our end line here, right? So let's look at the quadratic equation. The quadratic equation where A is equal to 1, right? B is equal to, let's see, 5, right? A is equal to 1, B is equal to 5, and C is equal to 6. So, C is equal to 1, B is equal to 5, and C is equal to 6. We're expecting a real and different values, right? Good. So we have the rules are distant and real, where root 1 is equal to minus 2 and root 2 is equal to minus 3. Let's also check for the equal root. Let's look at where a is equal to 1, b is equal to 6, and c is equal to 9. And this should give us the roots. The roots are equal and root 1 is equal to root 2, which is equal to minus 3. So let's just make a little correction in that aspect. Have equal to here, and we have our end line. We have our end line here. So on that we should make sure that everything is now okay. We have 1, right, 6 and 9, and everything is okay. The roots are equal and root 1 is equal to root 2, and which is equal to what? Minus 3. Now, so that is all. See, it is very easy. It is very easy if you know how to solve a quadratic equation in real life. You can just apply it to it and solve it easily. Thank you for watching this video. Please like, share, and make sure you subscribe to my YouTube channel. Thank you. See you in the next video.